In a universe of silence, one object finally spoke. For months, 3I Atlas drifted through the void, unpredictable, unsettling, undeniably artificial. But when the signal arrived, it wasn't noise, it was intent, a mathematical handshake from something that understands far more than we do. And in the very next breath, the object shifted direction, not drifting, but choosing. Humanity has waited millennia for a moment like this. Now it's here, and April 23rd may become the most important date in human history. If you find work like this valuable, don't forget to like and subscribe. Settle in now. Let's begin. On March 14th, 2025, something happened that no one in astronomy expected. In the early hours of that morning, every major telescope on Earth turned to the same coordinates in space. There was no coordinated instruction, no scheduled event, no planned observation run. The systems simply aligned because something at that position created a disturbance too significant to ignore. For months before that moment, scientists had been tracking an object moving through the outer regions of the solar system. It was known as 3I Atlas, written as the number 3, followed by the capital letter I and the word Atlas. It appeared to be another interstellar traveler, the kind of object that drifts in from beyond the sun's gravitational hold. Instruments followed it the way they follow any newcomer from deep space, with routine measurements, predictable patterns, and no expectation that it would behave differently from other interstellar debris. Normally, objects that enter the solar system follow orbital paths that can be described with straightforward mathematics. Comets arc around the sun along trajectories influenced by gravity and the pressure of solar radiation. Asteroids obey the motion described by Newton's laws, where changes in direction require an applied force. Nothing about these familiar rules suggested that 3I Atlas would suddenly alter its course. Yet that is precisely what happened. Instead of continuing along a predictable path, the object shifted in a way that implied active control. It did not drift, it steered. No known natural process can explain such behavior. Then, 3 days before the world learned what was coming, the object transmitted something. It was not a burst of static, not a spike of electromagnetic radiation, and not the type of natural emission produced by a comet or asteroid. It was a signal with structure. It displayed consistency, intention, and mathematical order. The message could not be dismissed as noise. While the object continued its slow approach toward the inner solar system, the signal repeated, and instruments around the planet kept receiving it. As those signals arrived, they carried the weight of a realization humanity has considered for centuries. The possibility that we are not alone. The situation was not a matter of speculation or science fiction. It was evidence arriving through the detectors in real time. When the first alert appeared at 2:47 in the morning Greenwich Mean Time, observations were underway at the Mount Aya Observatory in Hawaii. The astronomer on duty, Dr. Sarah Chen, had settled into a routine shift, the type where she monitored faint dots moving against the dark field of the sky. Her task, like that of many astronomers working in similar facilities, was to keep track of objects that might pass near Earth. Most of these objects turn out to be harmless. The systems scan, categorize, and log them, and the night continues without incident. But then her display lit up with multiple alerts, not from one system, but from 17 independent observing networks. These alerts came from facilities spread across the globe, including the Very Large Telescope in Chile, the Arecibo Replacement Array in Puerto Rico, and the Square Kilometer Array in South Africa, spelled out as square kilometer rather than written with the symbol. All of them detected the same signal at the same microsecond. That coincidence alone was extraordinary. Telescopes do not synchronize spontaneously unless they detect something that stands out against the background of the universe. Because instruments operate independently, slight timing differences are normal. A perfectly matched detection across systems in different hemispheres is nearly impossible unless the source is unmistakable. For that reason, Dr. Chen's first assumption was a technical fault. Her second was a coordinated network intrusion. Only after checking for system errors did she consider a third option, that the detection was real. The source coordinates matched the location of 3I Atlas, which at that moment was approximately 2.4 astronomical units from Earth. 1 astronomical unit is the average distance between Earth and the Sun, so 2.4 astronomical units equal roughly 223 million miles, a distance comparable to the space between the Sun and Mars. That range is far enough that no immediate danger seemed likely, yet close enough that the event could not be dismissed. The nature of the signal itself deepened the mystery. It was not carried by radio waves or any known form of electromagnetic emission. Instead, it arrived through variations in gravitational waves. Gravitational waves are distortions in the fabric of space-time, predicted by Albert Einstein in his general theory of relativity. They are usually created only by extremely energetic events such as merging black holes or neutron stars spiraling together. These waves ripple outward like the spread of circles when a pebble enters still water. Yet the modulation associated with 3I Atlas was controlled and patterned. The object seemed to be shaping space-time deliberately, sending information through extremely subtle variations in gravitational intensity. Within 40 minutes, every major space agency received the same data. The list included NASA's Jet Propulsion Laboratory in California, the European Space Agency headquarters in Paris, Roscosmos in Moscow, the China National Space Administration in Beijing, and the Indian Space Research Organization in Bangalore. For once, there were no disputes over jurisdiction or secrecy. The phenomenon did not fall into any political boundary. The analysis required collaboration at the species level, not the national one. Preliminary results arrived 3 hours later. Dr. Marcus Webb of the MIT Kavli Institute later explained that the structure of the signal was evident immediately. Natural background noise has randomness. Cosmic radiation varies with irregularity, but the patterns received from 3I Atlas were organized with mathematical precision, repeating every 47 minutes with 0 deviation. Natural systems rarely achieve such exact repetition. Pulsars, which are rotating neutron stars, release beams of radiation with remarkable stability, yet even they vary slightly. Quasars produce emissions in cycles, but these fluctuate with time. Even the most accurate atomic clocks drift by nanoseconds. The signal from the object did not drift. It maintained the interval of 47 minutes exactly. By 9 o'clock Eastern Time, an emergency meeting had been assembled at the Pentagon. By noon, a joint scientific team representing astronomy, physics, linguistics, cryptography, and human behavior gathered at a secure facility. The inclusion of psychologists was practical rather than speculative. Their focus was not on the nature of the signal sender, but on the possible human response. If the information reached the public, an outcome considered inevitable, the psychological effects needed to be understood. The early analysis revealed something unexpected. Encoded within the gravitational wave modulation were prime numbers. Prime numbers are integers, divisible only by 1 and themselves, such as 2, 3, 5, 7, 11, and 13. They are considered fundamental in mathematics and often proposed as a universal communication tool because any culture capable of arithmetic can recognize them. The signal paused, then repeated the first 140 primes in order. After this sequence completed twice, Another set of numbers appeared, the Fibonacci sequence. This sequence begins with 1, 1, 2, 3, 5, 8, and 13, each number forming from the sum of the two before it. The pattern appears in many natural structures, including the arrangement of leaves, the curves of shells, and the shapes of spiral galaxies. A breakthrough arrived when Dr. Yuki Tanaka of Tokyo University noticed a deeper pattern, one the automated systems had missed. The strength of each gravitational pulse corresponded to the digits of pi, spelled out as the ratio of a circle's circumference to its diameter, 3.14159. The signal extended this number to 32 decimal places with perfect accuracy. Pi is essential in geometry and physics, appearing in orbital calculations and in the way light bends around massive objects. As these layers of the transmission were decoded, the structure became clearer. The primes established numerical awareness. The Fibonacci sequence demonstrated recognition of natural patterns. The digits of pi showed understanding of geometry. These components formed a progression similar to how humans teach mathematical reasoning, from counting to pattern recognition to conceptual relationships. The signal resembled a structured introduction rather than a call for help or a broadcast of random information. When Dr. Chen reflected on the moment she understood what the data represented, she described it as realizing that something had been present in the dark all along, waiting patiently for recognition. Within 24 hours, parts of the analysis leaked online. A low-resolution spectrogram appeared on social platforms and spread globally. News agencies reported cautiously, though none captured the atmosphere within the scientific community. Researchers spoke of overnight collaborations, hastily assembled conferences, and the rapid exchange of data that normally takes weeks or months. Many understood that the significance of the discovery exceeded familiar scientific milestones. For decades, humans had listened for signals from elsewhere through programs such as SETI. Spacecraft like Voyager carried information outward in case another intelligence found them. Questions such as the Fermi paradox, why we see no signs of advanced civilizations despite the scale of the universe, remained open. Now, for the first time, there was evidence answering part of that question. Something had communicated. The signal was unambiguous and repeated. It implied awareness, intention, and the capacity to reach across interstellar distances. Yet one question remained, unresolved and increasingly troubling. If the object intended to communicate, why did it wait? 3I Atlas had been in the solar system for months. It had passed the orbit of Jupiter and moved through the asteroid belt, any of which would have been a viable distance for transmitting. Instead, the signal began only when the object approached closer to the region where Earth could observe it clearly. Scientists struggled to understand whether the timing was strategic, coincidental, or indicative of something not yet considered. To explore the question, analysts reviewed earlier detections. On January 8, 2025, the Atlas survey system in Hawaii, written fully as the Asteroid Terrestrial Impact Last Alert System, registered an anomaly. Atlas routinely scans for near-Earth objects, cataloging asteroids and comets that might intersect Earth's orbit. Over the years, it has logged more than 700 asteroids and 66 comets. The system performs this work continuously, quietly, and with little public attention, simply doing its job. Although the Atlas survey system had classified the object as routine, this particular body did not behave like the typical material that passes through our solar system. The first indication of something unusual appeared in its trajectory. Most objects bound to the Sun travel within a broad, shared plane known as the ecliptic. This plane exists because our solar system formed about 4.6 billion years ago. from a rotating disk of gas and dust, and the residual angular momentum left nearly everything orbiting in a similar alignment. The arrangement is often compared to thin circular layers stacked together, all turning in the same direction. Even comets and asteroids that have been perturbed by gravitational interactions tend to follow paths that still relate to this overall structure. In contrast, the path of 3I Atlas entered the solar system at an angle of approximately 47 degrees relative to the ecliptic. While not impossible for an interstellar arrival, since an object from outside the solar system can approach from nearly any direction, it was still notable enough to draw scientific attention. Its velocity also contributed to the sense that something was different. The object was moving at about 31 kilometers per second relative to the Sun, which translates to roughly 6,900 miles per hour. Speeds in this range are expected for material originating from outside the Sun's gravitational influence, so this alone did not suggest anything extraordinary. The astronomer who first logged the object, Dr. Robert Work, had prior experience recognizing unusual interstellar visitors. He had also been involved in the discovery of Oumuamua back in 2017. Following normal procedure, he used spectroscopy to determine the object's composition by examining how it absorbed and reflected light. He applied photometry to measure small variations in brightness over time, which can reveal rotation. Then he used astrometry to calculate its precise trajectory. All three methods suggested nothing that was outside known categories. The object seemed to have a rocky surface, potentially with patches of ice, and it measured an estimated 400 meters in length and around 40 meters in width. It had an elongated, cigar-like shape, reminiscent of Oumuamua. Such shapes are not uncommon among interstellar travelers because long, narrow bodies tend to tumble more slowly and resist destabilizing forces during long periods spent between stars. The classification assigned to the object was I-type asteroid, with the letter I indicating interstellar origin. Being the third object of this type ever confirmed, it received the designation 3I. The name Atlas referred simply to the survey system that identified it. Under ordinary circumstances, this would have been the end of the matter. Data recorded, paperwork completed, and researchers moving on to the next discovery. However, one astronomer chose not to move on. Dr. Priya Natarajan of Yale University, whose work usually focuses on gravitational lensing and the distribution of dark matter, encountered Work's report during a break and felt that something about it seemed inconsistent. She could not identify the problem immediately. Instead, it manifested as a sense that the trajectory did not align with the expected conditions. She retrieved the data and ran it through her modeling software. When the results appeared unusual, she repeated the process. The discrepancy persisted each time she tested it. Her concern centered on a concept known as hyperbolic excess velocity. When an object enters the solar system from interstellar space, its speed is shaped by the Sun's gravitational pull. After accounting for this pull, the object's remaining speed can be compared to typical values expected from nearby stellar regions. Oumuamua, for example, had a hyperbolic excess velocity of approximately 26.33 kilometers per second, well within the range expected for an object arriving from the local stellar environment. For 3I Atlas, the value came out to roughly 31.2 kilometers per second. Although somewhat high, this might have been acceptable if its past trajectory pointed to a specific place of origin. When Dr. Natarajan traced its motion backward across centuries of travel, no such point emerged. Her modeling showed that the object's path did not intersect with any known star within 50 light-years for at least the past 1,000 years. The absence of a clear origin raised difficult questions. Interstellar space is vast, but objects tend to form in or be ejected from star systems. A trajectory leading back to an empty region without stars or gas clouds meant that the object had not followed the usual processes of formation or ejection. It was similar to someone arriving at a location without any possible route explaining how they got there. The more she reviewed the path, the more apparent it became that the numbers did not line up with expectations. Meanwhile, at the European Southern Observatory in Chile, routine follow-up observations were underway. The purpose of such observations is to verify earlier measurements and ensure that the recorded path and rotation of an object match predictions. During one of these observing runs, Dr. Friedrich Bachmann noticed an inconsistency in the photometric data. 3I Atlas was rotating as it traveled, which is normal for any asteroid, but the rate of rotation was slowly changing. On January 8th, it completed one rotation roughly every 6.7 hours. By January 22nd, the rotation period had increased to about 6.9 hours. Such a change is not expected in deep space. Without air resistance or friction, an object's rotation should remain constant unless acted upon by an external force. Collisions might change rotation, but no signs of impact were present. Outgassing, common in comets when ice turns to vapor under solar heating, can also alter spin, but spectroscopic data showed no evidence of such volatiles on the surface of 3I Atlas. Bachmann published a paper describing this unexpected deceleration. In only 1 week, it received 47 citations, not because researchers agreed with his proposed explanations, but because teams across the globe independently confirmed the same pattern of rotational slowing. Understanding rotational change requires familiarity with the conservation of angular momentum. When mass spreads outward, rotation slows. When mass contracts inward, rotation speeds up. Ice skaters demonstrate this principle when pulling their arms close to their bodies to spin faster and extending them to slow down. For 3I Atlas to reduce its rotation rate, it would have needed to redistribute mass or alter its shape. Natural asteroids do not behave this way. These findings prompted observatories around the world to add the object to their observation lists. The Hubble Space Telescope obtained high-resolution imagery. The James Webb Space Telescope conducted infrared analysis to determine the surface temperature and composition. Radio telescopes monitored for emissions but found nothing definitive. Even so, each new dataset reinforced the impression that the object's behavior did not match that of ordinary interstellar rocks. During a conference on February 18th in Pasadena, researchers presented their observations. Dr. Sarah Chen from the Mount Aya Observatory attended. Across multiple presentations, teams explained their methodologies and showed their results. Although the language differed from one group to another, a shared question lingered unspoken: whether the object could be natural at all. The question eventually surfaced when a graduate student in the audience asked at what point accumulating evidence should prompt scientists to consider a non-natural explanation. While the session concluded without a direct answer, private discussions afterward reflected the weight of the question. Researchers acknowledged that while extraordinary claims require extraordinary evidence, there comes a point when unexplained data cannot be ignored simply because it challenges existing assumptions. 3 weeks after that conference, 3I Atlas provided the most significant piece of evidence yet. The object changed its trajectory. On March 7th, 1 week before the gravitational wave signal would be detected, Dr. Elena Vulov at the Russian Academy of Sciences calculated the object's projected path using standard orbital models. She accounted for gravitational forces from the Sun and planets, solar wind pressure, and radiation effects. Previous calculations had shown that the object would pass near the orbit of Mars on March 28th, before moving outward and leaving the solar system. Confidence in this projection was extremely high. However, when Vulov ran the new data, The predicted position no longer matched the observed location. She checked for errors in software and compared the input data with independent sources. All values were correct. Seeking further confirmation, she consulted Dr. James Chen at NASA's Jet Propulsion Laboratory, a specialist in trajectory modeling. After reviewing the data through multiple independent models, he found that every calculation placed the object about 180 kilometers from its actual measured position. For perspective, 180 kilometers is a significant deviation, far larger than the margin of error associated with high-precision astronomical tracking. The difference was not the result of random error or gravitational influences from other bodies. It had accumulated gradually over 6 days, forming a smooth, deliberate curve in the plotted trajectory. Confirmation soon followed from observatories in Europe, Asia, and North America. The object was not following a ballistic path determined solely by gravity. It was maneuvering. After the object's course changes were confirmed, researchers turned their attention to understanding what kind of force could produce such motion. Among them was Dr. Marcus Webb from the Massachusetts Institute of Technology, known not only for his work on analyzing the gravitational wave signal, but also for his expertise in spacecraft propulsion. He examined the positional data and calculated the magnitude of acceleration required to shift the object by approximately 180 kilometers over the span of 6 days. His findings, released in a rapid preprint that drew wide attention, indicated that 3I Atlas would need to generate about 0.003 meters per second squared of continuous acceleration. At first, that number may sound extremely small. When compared to the strong thrust produced by most chemical rockets, it is indeed tiny. But small, steady forces behave differently in space. With no air resistance and almost no friction, even slight accelerations can accumulate over long durations and lead to large changes in trajectory. The key question became not whether such acceleration could move the object, but how an object of that scale could sustain it without leaving detectable signs. Dr. Webb estimated the object's mass based on its dimensions and likely rocky composition. A length of roughly 400 meters and a width around 40 meters suggested a mass near 2.5 million tons. To maintain the necessary thrust for 6 days, such a body would require energy output on the order of 1,200 gigawatts of continuous power. To put that into perspective, 1 gigawatt equals 1 billion watts, and 1,200 gigawatts is about 12 times the electricity generation capacity of the entire United States, sustained over that same 6-day period. Yet all observations showed no thermal signature, no visible exhaust, and no expelled propellant. It was as if the object produced force without releasing any form of detectable byproduct. On March 8th, NASA organized an emergency virtual meeting that brought more than 40 scientists onto a single video call. The discussion moved quickly. Participants compared measurements, proposed possible mechanisms, and evaluated whether any natural explanation could match the observed behavior. One suggestion was that sublimation of ice on the surface might be creating a rocket-like effect. If sunlight caused frozen material to vaporize, the outgoing gas could provide thrust, but spectral analysis of the object indicated no sign of volatile substances such as water ice, carbon dioxide, or methane. The surface appeared to consist mostly of rock and metal, offering no support for sublimation. Another possibility raised was the Yarkovsky effect. This effect occurs when one side of an asteroid becomes warmer than the other, causing a tiny imbalance in thermal radiation that can slowly alter an orbit. However, forces from the Yarkovsky effect are extremely small, measured in values near 10 to the negative 14 meters per second squared. These accelerations are millions of times weaker than what 3I Atlas was exhibiting. A solar sail was also considered, but no reflective material appeared on any of the high-resolution observations. Even the idea of an unseen gravitational influence was investigated, though there were no signs of additional large bodies in the region capable of producing such a pull. Each possibility was tested against the available data. Each one failed to match the scale, precision, and sustained nature of the acceleration. With 5 independent observation networks presenting consistent measurements, equipment error was ruled out. Eventually, one participant stated the conclusion that the numbers pointed toward the object appeared to possess some form of internal propulsion system, operating without detectable emissions and generating controlled thrust over long intervals. The comment brought an abrupt pause to the meeting. It was not a claim made lightly. It simply reflected that all known natural processes had been eliminated. The conversation then shifted to what action, if any, humanity should take in response. Over past decades, scientists had created guidelines for handling potential contact with extraterrestrial intelligence. Groups such as the Search for Extraterrestrial Intelligence, known as SETI, developed response protocols. The International Academy of Astronautics established principles for communication in the event that a signal were detected. These guidelines assumed that a message would arrive first and that there would be time to analyze it before deciding on any reply. None of the protocols addressed a situation in which an unidentified object was already inside the solar system, already maneuvering, and already demonstrating control. NASA's leadership reached a cautious decision. Observations would continue at maximum capacity, but no attempts would be made to contact the object. Without understanding the nature or purpose of its movements, initiating communication carried risks. The scientific community agreed that collecting data and tracking the object's behavior were the highest priorities. For 3 days, observatories worldwide monitored 3I Atlas with increased precision. The course changes continued, each one small yet exact, forming an overall pattern that indicated navigation rather than drifting. Meanwhile, amateur astronomers began noticing irregularities. When many large observatories point at the same location, amateurs often follow the same target. By March 10th, online forums saw growing discussion. Some shared telescope images of the object's movement, noting that its path did not fully match predicted models. Although the broader public did not yet understand the implications, awareness spread quickly among those who follow astronomical observations. Within research circles, the meaning of the controlled propulsion was becoming clearer. The object was not behaving like a natural asteroid or comet. It displayed characteristics expected of an artificial spacecraft. This understanding remained restricted to confidential reports, yet the underlying data drove scientists to re-evaluate their assumptions about what they were witnessing. On March 13th, Dr. Sarah Chen resumed the night shift at the Mount Aya Observatory. She had been observing the object for several consecutive nights and had watched it adjust its trajectory in ways that could not be explained by natural forces. Her notes from that night reflect a shift in mindset, moving from attempts to justify the behavior through known physics to accepting that the explanations must lie elsewhere. 12 hours after that shift began, 3I Atlas stopped maneuvering. Its path stabilized, and then, at 2:47 in the morning, on March 14th, it transmitted a gravitational wave signal. Before the signal analysis would redefine humanity's understanding of the object, researchers focused on one more question: what could be learned from its trajectory alone? Spacecraft paths carry what some engineers call signatures. When a spacecraft travels from Earth to another planet, its movement reflects choices made by mission planners. Techniques such as Hohmann transfer orbits, gravity assists, and delta-v calculations shape the path. Each maneuver reveals something about the propulsion used and the mission's intended destination. Natural objects also have signatures, although their paths are driven by gravity and initial conditions. Comets follow arcs, determined by interaction with the Sunday asteroids. Trace orbits influenced by countless small gravitational tugs. These paths can be complex, yet still consistent with known physical laws. 3I Atlas showed a different pattern. Its trajectory included repeated course corrections at regular intervals. A mathematician at Princeton's Institute for Advanced Study, Dr. Catherine Xiao, reviewed the data. Her background was in patterns and number theory rather than astronomy, but the trajectory caught her attention. She reduced the data to basic mathematical components: changes in position, shifts in velocity, and magnitudes of acceleration. Through this simplified view, she noticed that the adjustments occurred at consistent intervals of 6 hours, 12 hours, 18 hours, and 24 hours. All of these values were multiples of 6, a type of regularity that natural celestial mechanics rarely produce. She also analyzed the angles of each correction. The first correction corresponded to an angle equal to pi divided by 6. The second matched pi divided by 4. The third was equal to pi divided by 3. These values were not approximate. They were exact to 9 decimal places. The presence of pi, the mathematical ratio of a circle's circumference to its diameter, suggested a structured choice rather than a natural perturbation. The trajectory seemed to encode geometric knowledge. Her findings were shared with the scientific community and soon confirmed by independent teams. Dr. James Chen at NASA's Jet Propulsion Laboratory extended the analysis. He translated the sequence of maneuver magnitudes into binary values, assigning 1 to larger corrections and 0 to smaller ones. The resulting pattern alternated perfectly between 1 and 0 across 18 consecutive maneuvers. Such a sequence is not required for navigation. Instead, it suggested a deliberate insertion of a recognizable mathematical structure into the object's motion. The pattern communicated that the object was not obeying gravity alone. It was selecting its path with intention. And as Dr. Chen continued his work, he discovered another detail, one that raised even more questions. He calculated the fuel efficiency of the trajectory. In spacecraft engineering, there is a basic idea used to understand how far and how precisely a craft can travel. It is called delta V, written as the Greek letter delta, followed by the letter V, meaning change in velocity. Delta V describes the total amount of speed change a spacecraft can produce with the fuel it carries. A higher delta V means more freedom to maneuver. Human spacecraft are always limited by this value because fuel is heavy, and every adjustment requires some of it. Even the Apollo missions, traveling to the moon and back, had to plan each maneuver with extreme care. They carried only the minimum fuel needed to complete the mission, so there was no room for waste. By March 13th, 3I Atlas had executed 47 separate course changes. Dr. James Chen calculated the total delta V represented by these adjustments. His number came out to about 2.7 kilometers per second. For reference, the Voyager spacecraft, which is one of the most efficient probes ever built, had roughly 3 kilometers per second of delta V available for its entire mission. Voyager also weighed only 722 kilograms, less than 1 ton. 3I Atlas, based on its observed size and density, weighed an estimated 2.5 million tons. That means the object was more than 3,000 times heavier than Voyager, yet was performing maneuvers requiring nearly the same total change in velocity. The energy demanded by such maneuvering is far beyond current human capability. Dr. Chen repeated the calculations several times to be certain the numbers remained the same. Whatever system of propulsion 3I Atlas used, It was at least 1,000 times more efficient than the best ion drives available today. Ion drives consume large amounts of electrical power to expel charged particles at high speed, producing a steady but gentle thrust. Even the most advanced designs would struggle to move a craft only a few tons in mass across interplanetary space. For a body measuring millions of tons to maneuver with ease suggested a form of propulsion far outside familiar engineering. On March 12th, a research group in the Department of Aeronautics and Astronautics at the Massachusetts Institute of Technology decided to model the object's movement using theoretical propulsion technologies. They asked a simple question: if humanity attempted to reproduce the same trajectory changes using the best engines we could imagine, would it be possible? They chose a nuclear thermal rocket for the simulation. This type of engine heats hydrogen or another propellant with a nuclear reactor, creating thrust at higher efficiency than chemical rockets. Although such engines have been discussed for decades, none have been built at the scale needed for deep space missions. The model showed that to match the acceleration of 3I Atlas, a spacecraft would need to launch with a mass of about 5,000 tons, nearly all of it fuel. That mass is similar to that of a large naval vessel on Earth. Even then, the projected performance would remain far below what 3I Atlas displayed. The lead researcher, Dr. Paolo Lozano, summarized the findings by comparing the technological gap to the difference between a steam engine and the tools available to builders thousands of years ago. The concept of propulsion could be recognized, he wrote, but the underlying physics might appear almost impossible to understand. As researchers examined the trajectory more closely, they noticed something else. Dr. Catherine Schau, the mathematician who had identified geometric structure in the earlier course corrections, found an additional repeating pattern in the timing of the maneuvers. When plotted on a graph, the times at which the object adjusted its course did not form a smooth curve. Instead, the graph resembled a staircase pattern. The height of each step, measured in hours, matched a sequence already familiar to scientists: 1 hour, 1 hour, 2 hours, 3 hours, 5 hours, 8 hours, and 13 hours. These values form the Fibonacci sequence, where each number is the sum of the two that come before it. This same pattern appears in the structure of spiral galaxies, the curves of shells, and the arrangement of leaves on plants. In this case, however, it was appearing in the timing of maneuvers made by an object traveling between planets. The coincidence was unlikely. The pattern suggested deliberate placement, as though the object was introducing itself through mathematics well before any formal message arrived. When Dr. Sarah Chen reviewed this analysis on March 13th, she wrote in her log that researchers had been asking the wrong question. The issue was not whether the object was intelligent, but how long it had been trying to show that intelligence. She remained at the observatory for the rest of the night, even though she was not required to. According to her notes, she simply sensed that something important was approaching. At 2:47 in the morning, her computer displayed a cluster of alerts. 3I Atlas had stopped producing the subtle mathematical signals in its path. Now it was ready to transmit in full. The first detail to understand about the signal is that it was not designed for typical human senses. It did not use sound or light or radiation within the electromagnetic spectrum. Instead, it used gravitational waves, the faint ripples in space-time predicted by Albert Einstein. These waves are usually generated by extreme events, such as two black holes orbiting each other and eventually merging. When this happens, space-time curves and stretches, producing signals that spread outward across the universe. Instruments like the Laser Interferometer Gravitational Wave Observatory, known as LIGO, detect these signals by measuring changes far smaller than the width of a proton. The equipment needed is enormous. highly specialized, and extremely sensitive. Gravitational waves pass through matter without being absorbed or scattered, which makes them difficult to detect, but also makes them reliable for long-distance transmission. They cannot be blocked or interrupted by dust, gas, or magnetic fields. 3I Atlas did not generate waves through catastrophic events. Instead, it modulated them. That means it created precise variations in the amplitude and frequency of the waves. Such control implies a level of technological development far beyond current physics. One of the pioneers of gravitational wave detection, Dr. Rainer Weiss, was asked to review the data. After examining the raw measurements, he concluded that the signal demonstrated controlled manipulation of space-time curvature at levels thousands or even millions of years ahead of present-day technology. Researchers realized that they were observing a method of communication built on physical principles they could barely measure, let alone produce. An international decoding effort began within minutes. Emergency protocols created decades earlier were activated. Experts in cryptography searched for mathematical structure. Physicists analyzed the waveform. Linguists looked for organization and repetition. Mathematicians tested for recognizable sequences. Even musicians were included because of their ability to detect patterns hidden in complex signals. The first structural pattern was identified by Dr. Chen, who recognized that the signal did not vary continuously, but rather pulsed in discrete steps. Strong pulses alternated with weaker ones. This type of digital structure is used in many forms of communication on Earth and provided a starting point for analysis. When the pulses were interpreted as numbers, a clear sequence emerged. The prime numbers from 2 all the way through the first 140 values. Each prime number was represented through a specific arrangement of pulses. The full sequence required 47 minutes to transmit. When it finished, it began again with exact precision. The interval of 47 minutes matched the timing of the earlier trajectory corrections, suggesting that the same intelligence shaped both patterns. Researchers continued their analysis and found the Fibonacci sequence embedded within another section of the transmission. The pulses increased to represent 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and 144. Then the sequence reversed. It was a demonstration of familiarity with mathematical patterns found across nature. But the most striking discovery came from the collaboration between Dr. Yuki Tanaka, the astrophysicist who had found the digits of pi in an earlier portion of the signal, and Dr. Kenji Watanabe, a linguist specializing in the structure of human languages. Watanabe observed that the message was arranged in a teaching pattern. It began with counting, then progressed to pattern recognition, then to geometric understanding. This progression resembled the way humans introduce new concepts to someone who does not share their language. A deeper layer of the signal emerged when Dr. Tanaka examined the frequency variations of the gravitational waves. Using a Fourier analysis to break down the waveform into its components, she found another code. When converted into numerical values and interpreted as spatial coordinates, the data pointed to specific star systems. The first coordinate referenced Proxima Centauri at a distance of 4.24 light-years from Earth. The next pointed to Barnard's star at 5.96 light-years. Another referenced Wolf 359 at 7.86 light-years. In total, there were 12 sets of coordinates, all corresponding to stars within 20 light-years of Earth. Next to each coordinate was a number. These values represented time, not as dates, but as durations, measured in what were eventually decoded as Earth years. The listed times ranged from 6,800 years for Proxima Centauri to 9,200 years for Barnard's star and 12,400 years for Wolf 359. The interpretation was clear. The object was not telling us where it originated. It was listing the places it had visited and how long ago those visits occurred. The implication was immense. Based on the timestamps, the object had traveled among nearby star systems for more than 120,000 years, and now it had arrived in our solar system. But the message was not finished. The final portion of the gravitational wave signal, identified by a research group at the successor facility to the Arecibo Observatory in Puerto Rico, proved to be the most technically demanding to decode. In this last section, the signal stopped behaving like a simple sequence of pulses and shifted into a three-dimensional form of encoding. The amplitude, the frequency, and the phase of the gravitational waves each carried a separate layer of information. When these layers were decoded together and translated into a visual model, they produced an image. It was not a picture of an unfamiliar object, nor a map of stars, nor a representation of any organism. Instead, it displayed something more basic: the hydrogen atom. Hydrogen, made of one proton and one electron, is the simplest and most abundant element in the universe. The image delivered by the signal showed not just a crude outline of this atom, but a detailed mathematical rendering. It included the electron probability cloud, which describes where the electron is likely to be found. It showed the distinct energy levels that electrons can occupy. It even represented the hyperfine structure of hydrogen, a subtle detail that arises from interactions between the spins of the electron and proton. Depicting these features requires an understanding of quantum mechanics, suggesting that whoever produced the signal understood the same fundamental physics that humans study. Under the diagram of the hydrogen atom appeared another sequence. This one contained the exact frequency of hydrogen's well-known emission line, 140020.40575 1 MHz. It is one of the most important frequencies in radio astronomy. When hydrogen atoms in interstellar space change their energy state, they release radiation at this precise frequency. Because hydrogen is everywhere, this emission creates a kind of universal reference point. For decades, the search for extraterrestrial intelligence, or SETI, has treated this frequency as a natural choice for communication. It is sometimes called the cosmic dial tone, a frequency that any civilization knowledgeable about astronomy might deliberately use. Researchers soon brought in Dr. Jill Tarter, former director of SETI, to help interpret the significance of the hydrogen section. After spending 40 years searching for an intelligent signal and finding none, she immediately recognized what the transmission implied. Hydrogen was being shown because humans understand hydrogen. The frequency was being used because humans listen at that frequency. The signal was acknowledging our scientific knowledge. It was demonstrating mutual awareness. Over the next 2 days, decoding continued. Every 12 hours, new layers of the message were uncovered. One section demonstrated the Pythagorean theorem through a precise mathematical construction. Another section displayed the base 10 number system, the one humans use for counting, suggesting that the sender either recognized our numerical system or selected a format simple enough to be universally interpreted. Another part of the signal listed each element in the periodic table, from atomic number 1 through atomic number 118. Among these elements, carbon, atomic number 6, appeared highlighted. Carbon is central to life as humans understand it, forming the structural basis of many biological molecules. By isolating carbon in the signal, the sender seemed to be asking a question in mathematical form. Do you recognize this pattern? Do you know why this element matters? Are you, in some way, similar to us? On March 16th, 72 hours after the first transmission, Dr. Sarah Chen addressed an international committee assembled by video link. Representatives from major space agencies, heads of state, and officials from global organizations participated. Their central question was whether humanity should respond. Dr. Chen pointed out that a response had already been given long before this moment. Every radio wave emitted by human technology over the last century, every broadcast, and every deep space probe had already spread outward into the surrounding cosmos. The object had likely observed these emissions long before it approached Earth. It had not arrived without context. It already knew who we were. By March 17th, 3 days after the signal began, Dr. James Chen reran the trajectory calculations. The numbers matched earlier results. 3I Atlas was 2.1 astronomical units from Earth, approximately 195 million miles. In everyday terms, this distance seems immense, but in astronomical terms, it is relatively close, roughly comparable to the distance between two neighboring houses on a much larger scale. Updated projections showed that the object's navigation had changed. The complex geometric course corrections seen earlier were gone. Instead, the trajectory had become direct and steady. The new path would bring it to its closest point to Earth on April 23rd, 37 days ahead. At that time, it would be 0.7 astronomical units away, around 65 million miles. This is not close enough to raise concerns about collision or planetary safety. It is, however, close enough for clear observation from Earth and close enough for the object to collect detailed data about our planet. Astronomers began calculating how bright the object would appear in the night sky. Dr. Lisa Hammond of the Royal Astronomical Society determined that around April 15th, the object would reach approximately magnitude 3, similar in brightness to the stars in Orion's belt. By April 20th, it would reach magnitude 1, comparable to the brightness of Arcturus. At its closest approach, it would reach magnitude -1, brighter than any star in the sky except Sirius. It would be easily visible without a telescope. Questions arose about whether this visibility could be concealed from the public. The answer was clear. Astronomical observations are conducted by thousands of professionals and amateurs around the world. An object that bright and moving across the sky cannot be hidden. Observations from amateurs were already accumulating, many noting the object's unusual behavior. While brightness captured public attention, astronomers focused on what the object's final trajectory implied. It was not merely approaching Earth, it was maneuvering into a highly specific alignment. Dr. Elena Vulov at the Russian Academy of Sciences noticed that on April 23rd at 14:37 Coordinated Universal Time, 3I Atlas would be positioned so that, from its vantage point, Earth would pass directly in front of the Sunday. The alignment would not create an eclipse for viewers on Earth because the object was too distant and too small. However, from the object's perspective, Earth would cross the Sun's disk, producing what astronomers call a transit. This is the same method humans use to study planets around other stars. When a planet transits its star, the star's brightness dips slightly, and the planet appears as a small silhouette. From this exact alignment, the object could observe Earth with exceptional clarity. The Chinese National Space Administration conducted an analysis of what could be seen from 0.7 astronomical units with optical systems similar to human instruments such as the Hubble Space Telescope. Their results indicated that surface features on Earth could be resolved down to approximately 50 meters. Large buildings would be visible, as well as patterns of city lights at night, major weather systems, and regions of vegetation. If the object possessed optical technology significantly more advanced than ours, the resolution could be far sharper. Interest grew not only in what the object could see, but how long it had been watching. Dr. Marcus Webb, using detailed trajectory modeling and hyperbolic excess velocity estimates, traced the object's path back over several months. His findings, published on March 19th, showed that 3I Atlas had entered the solar system roughly 8 months earlier, in July 2024, crossing the heliopause, the boundary marking the outer edge of the Sun's influence. From that moment forward, the object had moved through the solar system in ways that implied observation. It traveled within 0.3 astronomical units of Jupiter in September 2024, close enough to gather extensive information about the planet and its moons. It passed through the asteroid belt in November. Between December and February, it slowed its motion and remained near a position approximately 3.5 astronomical units from the Sunday. This location provided a wide view of the inner solar system. According to Dr. Webb, the object's behavior during those months pointed toward a period of dedicated observation rather than simple transit. Researchers then calculated the energy required for such a mission profile, traveling from a nearby star system, decelerating upon entry into the solar system, maintaining extended observation periods, and then performing multiple controlled maneuvers in the inner regions of the solar system would demand levels of power that exceed the total energy output of human civilization over centuries. Yet there was no indication that 3I Atlas was operating near any limit of its capabilities. On March 20th, the European Space Agency convened an emergency international meeting with NASA, Roscosmos, the China National Space Administration, the Japan Aerospace Exploration Agency, and the Indian Space Research Organization. The goal was to consider possible responses. 3 main options were identified. The first was to do nothing, continuing observation without attempting communication. This approach carried the risk of appearing passive or uncertain. The second option was active communication, sending a mathematical message in return. While this would show understanding, it also carried the risk of sending an unintended signal. The third option involved launching a probe as quickly as possible. Engineers calculated that one existing orbital satellite could be modified and sent toward the object if launched within a week. Though the resulting craft would be simple and could be interpreted in unpredictable ways, discussions continued for 7 hours. No consensus is reached. Every proposed response to 3I Atlas carried a different kind of risk. Some felt too slow, expecting that silence might help avoid misunderstanding. Others felt too bold, suggesting actions that could be misread by an intelligence we did not yet understand. While governments debated probabilities and consequences, a separate event unfolded that bypassed every official discussion. On March 22nd, at 3:47 in the morning local time, the Arecibo Successor Facility in Puerto Rico registered an unauthorized access alert. A system designed for both observation and controlled signal transmission had been taken over remotely. Safety protocols were bypassed, and the main radio dish moved into position, pointing directly at the known coordinates of 3I Atlas. A transmission began. It lasted 17 seconds at maximum broadcast power before automated security systems shut it down. 17 seconds was more than enough time to send a complete message into space. Data logs showed that the command sequence originated from credentials assigned to Dr. Sarah Chen. Dr. Chen was not at the facility. She was thousands of miles away in Hawaii, asleep, her laptop untouched. Her access codes were supposed to be secured, encrypted, and stored within isolated systems. Despite these safeguards, someone used those codes to activate one of the most powerful radio transmitters on Earth. Security teams traced the connection. The origin point was not in Hawaii. It came from an address linked to the European Organization for Nuclear Research, known as CERN, in Geneva. The content of the transmission deepened the concern. It was not a random broadcast. It was the Arecibo message, originally sent in 1974 toward the globular star cluster M13. That historic message used binary encoding to describe basic human information: our DNA structure, the solar system, simple stick-figure representations of humans, and the atomic numbers of key elements. In 1974, the message had been more symbolic than functional because the target was so far away. But this time, the recipient was close enough to receive it within minutes. At the speed of light, 186,282 miles per second, the signal would reach 3I Atlas in roughly 17 minutes. NASA released an urgent statement clarifying that the transmission had not been authorized and did not represent the position of any government or scientific institution. But statements could not reverse a message already traveling through space. At 4:15 in the morning Hawaii time, Dr. Chen received the call, informing her that someone had used her credentials. As she listened, she realized she had already seen something in the gravitational wave signal that now felt relevant, a sequence of numbers corresponding to Earth coordinates. At the time, the team had not understood why the coordinates pointed directly to CERN. Now, this detail no longer seemed abstract. It suggested a connection between the content of the message and the location from which the unauthorized transmission had been sent. At 1:47 in the morning Geneva time, 2 hours before the breach was traced, CERN security systems had detected unusual activity in one of the underground service tunnels. These tunnels, built to house components of the Large Hadron Collider, remained sealed during maintenance. Motion sensors reported movement. Cameras showed nothing unusual. However, magnetic field monitors detected a shifting distortion moving at a steady pace. These instruments are designed to measure extremely small fluctuations, far below the threshold of human perception. The recorded distortion moved purposefully toward the control room associated with the network access point used in the transmission. When security staff reached the tunnel, it was empty. They did, however, find physical evidence. On the metal surface of a sealed door was a mark that appeared burned into the material, not scratched or drawn, but fused into the metal by heat or radiation. The mark was a diagram of the hydrogen atom, identical to the one encoded in the gravitational wave message. Below it were 3 numbers, 3, 7, and 2314. When placed into recognizable format, they represented April 23rd at 14:37, the exact time of 3I Atlas's closest approach to Earth. This detail added a new layer to the situation. The object was not only approaching, it had provided a timestamp that matched astronomical projections. It appeared to be counting down. With speculation rising, several scientific groups recommended returning to verified data rather than interpreting fragments of events. Reviewing what was known helped establish a baseline of certainty in a rapidly changing situation. The first confirmed fact was that the object could not be natural. By March 24th, 17 independent research teams across 12 countries had published analyses supporting this conclusion. Observations ruled out natural mechanisms that could explain its behavior. Outgassing was not possible due to the lack of volatile compounds detected in its spectrum. Radiation pressure could not account for the acceleration profiles observed. There were no nearby bodies capable of producing gravity assists that matched the trajectory. Measurement error had been eliminated through comparisons across multiple observatories. Dr. Alan Stern, principal investigator of NASA's New Horizons mission, summarized this understanding clearly. After 3 decades studying a wide variety of bodies in the solar system, asteroids, comets, and Kuiper Belt objects, he emphasized that natural bodies follow predictable physics. 3I Atlas did not. It followed physics, but it followed engineering-level control of physics. That combination indicated artificial design. Density measurements supported this. Spectroscopy suggested that the surface was composed of metallic and rocky material, similar to certain asteroid types. However, estimates of mass based on gravitational influence showed that the object was significantly lighter than expected, around 40% less dense than a solid body of the same size. This implied a partially hollow interior. While hollow planets or asteroids are common in science fiction, they do not form through natural geological processes. Hollow regions are indicative of internal structure or intentional construction. The second confirmed fact was that the object possessed an internal power source. On March 21st, the James Webb Space Telescope recorded a thermal anomaly on its surface. The majority of the object registered temperatures near -150 degrees Celsius, consistent with its distance from the Sunday. However, there was a localized hot region roughly 40 meters across. This region was 73 degrees Celsius warmer than surrounding areas. Dr. Martin Rees, the United Kingdom's Astronomer Royal, calculated that a passive object exposed to sunlight should show only minimal temperature variations across its surface. The measured differential required a continuous power output of approximately 2.4 megawatts. For comparison, that amount of energy could supply around 2,000 average American homes. The hotspot had been active for at least 8 months without signs of decline. The third confirmed fact involved communication. Although gravitational waves form the primary signal, radio telescopes detected an additional transmission near 1420.45751 MHz, the hydrogen line frequency encoded in the earlier message. The radio signal was extremely weak. Dr. Jill Tarter's team determined that if the object were transmitting at power levels comparable to human radar installations, the signal would be undetectable at its current distance. This suggested either intentionally low power or the use of radio waves as a secondary or subtle channel rather than a main communication method. Some researchers theorized that gravitational waves served as the main broadcast for any observer capable of detecting them, while the faint radio transmission functioned as a selective channel for those already familiar with the hydrogen frequency. Because SETI research programs have monitored this frequency for decades, such a choice might be intended for those who had demonstrated technological readiness to detect it. The fourth confirmed fact was that the object seemed to possess accurate knowledge of Earth-specific data. This included coordinates for CERN, the use of the base 10 numbering system, and references to Earth time units such as hours, days, and years. Base 10 mathematics is not universal. It originates from the number of digits on human hands. An extraterrestrial system could just as easily develop base 8 or base 12. Yet 3i Atlas used base 10 consistently in its transmissions. Dr. Kenji Watanabe, a linguistics specialist, noted that this was similar to encountering someone who not only speaks your language, but understands your regional dialect and cultural references. It suggested prolonged observation. The fifth confirmed fact addressed defense capability, or the lack of it. On March 23rd, the United States Space Force modeled intercept scenarios. The results, later leaked, showed that no current technology could reach or redirect 3i Atlas. Our fastest probe, the Parker Solar Probe, reached speeds above 43,000 miles per hour by utilizing the sun's gravity. 3i Atlas maintained comparable speeds while maneuvering freely in any direction. Our missiles cannot reach it. Our rockets cannot reach it. Even our fastest launch systems would fall behind long before getting close, because nothing we have today can chase a target that moves freely between planets and adjusts its path with precision. The tools we rely on to redirect hazardous asteroids, kinetic impactors that store momentum and strike a target after months of flight, would never arrive in time, and even if they did, the object could change direction slightly, and the entire effort would fail. Colonel Sarah Martinez from the United States Space Force explained this carefully during a congressional briefing. She noted that current space infrastructure was built for tracking satellites near Earth and responding to ordinary orbital problems. These tools were never meant for intercepting a maneuvering craft at interplanetary distances. Any form of engagement, she said, would require technologies humanity does not yet possess. Her statement was diplomatic, but the meaning was direct. We do not have a response plan because we do not have the capability. From here, the conversation quickly moved into difficult territory. Every scenario people proposed depended on assumptions we cannot verify. Scientists listed possibilities: peaceful contact, distant observation, scientific exchange, exploration of resources, or even expansion into new systems. But each idea required guessing what an unfamiliar intelligence might want. Dr. Lisa Hammond brought together a group at Oxford to examine this question. They included biologists, psychologists, anthropologists, and philosophers, each trying to build a picture from the limited information available. They studied the evidence for 3 days and produced a detailed report more than 200 pages long. Yet the conclusion fit into only 2 short paragraphs. According to the team, humanity does not have enough data to predict intent with any confidence. They added that across human history, contact between civilizations at different technological levels often ends poorly for the less advanced group, but applying human patterns to a non-human intelligence is not reliable science. They ended with one recommendation: we must prepare for every possibility at the same time. We should hope for stability, yet acknowledge we cannot tell the difference between safety and danger until events reveal themselves. This was the moment many researchers began to understand something new about the situation. 3i Atlas controlled every part of the interaction. It revealed itself when it chose. It communicated when it chose. It set its own course, and now that course placed it near Earth. Humanity was not guiding the encounter. We were observing an event already in motion. On March 26th, investigators cleared Dr. Sarah Chen of any involvement in the unauthorized transmission from the radio facility in Puerto Rico. Her access codes were used, but security footage at CERN, where the signal originated, showed no person entering the area during the relevant time. The burned hydrogen symbol found on the sealed door provided no additional clarity. Nothing on the cameras, nothing in the tunnel, only a heat-marked diagram, identical to the one in the signal. That evening, Chen went to a small church near the observatory. She did not go to pray. She went because she needed a quiet place to think. After weeks of non-stop analysis, briefings, meetings, and sudden discoveries, she was trying to understand what the data suggested without letting fear or assumption guide her. A reporter found her there and asked a simple question. After everything she had observed, after seeing evidence no generation before hers had ever faced, was she afraid? Chen paused before answering. She explained that she was not afraid of what the object was. She was concerned about what it seemed to understand. It had shown awareness of our scientific tools, our observation habits, our frequencies, even our weaknesses. It knew we were limited. It knew we were divided. It knew we were early in our development as a spacefaring species, yet it came here anyway. For Chen, the question was not what the object wanted. The question was why something so advanced would visit something so early in its progress. The reporter attempted a follow-up, but Chen's attention had shifted. She was looking at her phone, reading a message from an unknown sender. The subject line listed only a date, April 23rd. The message contained one sentence: "We've been waiting a long time to meet you." Attached was an image with a timestamp of March 26th at 9:47 p.m. It showed Earth from 2.0 astronomical units away, the same angle that matched the predicted position of 3I Atlas at that moment. 2 days later, on March 28th, the world watched the sky with a level of attention rarely shared across nations. People were not responding with panic, but with an old and familiar feeling, the same sense of curiosity and caution that has shaped human responses to unexplained events for more than a century. This was not the first time we looked upward and questioned our place in the universe. It was not even the first time something unusual made us reconsider what might be possible. The difference now was that the evidence was direct. History offered earlier moments when humanity believed something extraordinary was happening. In 1938, a dramatic radio broadcast of the War of the Worlds imitated live news reports and described an invasion from Mars. For years, the story claimed it caused widespread panic, but research later showed that only a small fraction of listeners believed it was real. Many of them did not run or hide. Instead, they tried to confirm the information. They called police, newspapers, and neighbors. The public reaction was more rational than the myth suggested. People looked for verification rather than assuming disaster. This pattern repeated in 1947 when an object crashed near Roswell, New Mexico. The initial report described a flying disc, but the explanation changed quickly, leading to decades of speculation about hidden truths. In the 1990s, the United States Air Force released documents showing it had been part of a classified program studying Soviet nuclear activity. The truth sat between imaginative theories and simple explanations. It was not extraterrestrial, but it was not a simple weather balloon either. The lesson was that secrecy creates gaps that people fill with the best information they have. In 1977, another unusual event occurred. A narrowband radio signal lasting 72 seconds reached the Big Ear Radio Telescope in Ohio. The pattern was so clean that the astronomer reviewing the data wrote, "Wow," in the margin. It never repeated, so science could not confirm its origin. For decades, it remained an open question, one unexplained signal, interesting but insufficient to change the world. In 2017, the interstellar object, Oumuamua, passed through our solar system. Its shape and slight non-gravitational acceleration did not match common models. Most scientists favored natural explanations, but a small number suggested it could be artificial. The possibility was discussed, but the community leaned toward conservative interpretations because no clear evidence supported anything else. Only years later did some researchers wonder whether humanity had dismissed the object too quickly out of caution or discomfort with unusual explanations. 3I Atlas changed that pattern entirely. This object was not a brief signal, not a historical misunderstanding, not a single observation that could be written off as noise. It was a moving craft, transmitting, adjusting its path, and demonstrating knowledge in ways that could not be ignored. It made no attempt to hide. It left a trail of clarity, not mystery. And as scientists revisited each earlier moment in history, they realized that the challenge before them was not deciding whether the event was real. It was understanding how to interpret it responsibly. This became known as the contact paradox. The recognition that while humanity has long wondered about meeting another intelligence, we have almost no framework to understand what such contact should look like, or what it would require from us. And now, for the first time, the paradox was no longer theoretical. It was approaching. For more than a century, humanity has imagined what alien contact might look like. Writers such as H.G. Wells, Arthur C. Clarke, and Carl Sagan built entire worlds around the question. Modern stories like Arrival, Contact, and The Expanse added new layers, exploring communication, conflict, and cooperation. Across thousands of novels, films, and series, we have examined every version of First Contact we could imagine. But now that something real has appeared, something that is truly here, none of our fiction matches it. In popular stories, visitors announce themselves in ways that are impossible to miss. They arrive in massive ships hanging over cities. They speak in familiar languages. They show intentions that are simple to understand, often invasion, sometimes peace. The drama builds quickly and the answer always arrives by the end. But 3I Atlas has done none of this. It has moved through our solar system for 8 months without saying what it wants. It sent one mathematical message and then went silent again. Its approach toward Earth is steady, direct, and controlled. It is not threatening, but it is not explaining anything either. This long pause, this careful distance, is producing a type of uncertainty that humans are not used to. The object is active, intelligent, and aware, yet it chooses not to reveal its purpose. The silence is not empty. It has weight, and scientists across disciplines keep returning to the same question. Is this hesitation part of its method? Science fiction author Ted Chiang, whose short story, Story of Your Life, became the film Arrival, discussed this on an NPR interview on March 31st. He noted that in his fictional story, communication begins almost immediately. The extraterrestrials present symbols, humans respond, and a language exchange follows within days. But that is fiction. In the real world, 3I Atlas seems to be demonstrating that first contact may begin not with communication, but with observation. It may start with gathering information, studying behavior, and waiting for conditions that only it understands. Chiang pointed out that the aliens in his story engaged because they needed something from humans. But if 3I Atlas needs nothing from us, then its silence becomes the message. We may not be participants in a dialogue. We may simply be subjects under examination. This idea, being observed rather than addressed, is keeping philosophers awake at night. What does a patient intelligence want? And what does it mean when it chooses not to tell us? At the same time, something completely new is shaping the public response. For the first time in human history, the entire planet can react together in real time. On April 1st, the hashtag 3I Atlas appeared on every major platform: Twitter, Instagram, TikTok, Reddit, all filled with content within hours. People posted jokes about alien visitors, theories about motives, videos of the night sky, and countless false images generated by artificial intelligence. Mixed into this noise were discussions, questions, and attempts to process what was happening. Yet beneath the humor and the speculation, an unusual global pattern emerged. Billions of people were watching the same object, wondering about the same questions, and reacting at the same moment. Earlier generations experienced major events through limited media. News took time to spread. Stories were filtered by editors, governments, or broadcasters. But now, the entire world is experiencing this together. The reaction is immediate, unfiltered, and shared. Researcher Dana Boyd published an early analysis on April 2nd. She argued that social media is creating a worldwide conversation that is both unified and fragmented. Unified because nearly everyone agrees something important is happening. Fragmented because interpretations differ widely. Cultural, religious, personal, and philosophical backgrounds shape how people understand the event. The result is a global experience without a global conclusion. In Jakarta, many gather for prayer. In Mumbai, people light fireworks. In New York, protests form, though the reasons behind them differ. In Tokyo, families prepare emergency kits. In Sao Paulo, street parties erupt. In Lagos, public debates fill city squares. In Sydney, beach crowds watch the horizon. It is the first event in human history where almost nobody is unaware. Everyone is doing something, and the few who are not are still thinking about it. This marks a major difference between now and earlier moments involving the possibility of extraterrestrial life. When Orson Welles performed War of the Worlds in 1938, most listeners had no idea it was happening. When the Roswell incident occurred in 1947, it remained a local event for days before becoming a national story. When the WOW signal was recorded in 1977, only a small scientific circle knew about it. Even when the interstellar object Oumuamua passed through in 2017, it reached only the astronomy community and a small portion of the public. But 3i Atlas is different. It is visible, persistent, and accessible to anyone with a telescope or even a smartphone camera. The entire world is paying attention. On April 3rd, Sarah Chen received another email from the unknown sender. The subject line read, "You're asking the right questions." The message contained a sequence of short statements. 1938. They imagined invasion. 1947. They feared invasion. 1977. They hoped for contact. 2017. They missed us. 2025. They're ready. Are you? Chen forwarded it to NASA security. An investigation traced the server route to a large facility in Iceland, but reached no further. Whoever sent the message understood digital concealment well, but what troubled Chen was not the sender's identity, it was the message itself. The repeated phrase, "They're ready," stayed on her mind. Ready for what? Ready in what sense? And who exactly was meant by they? Only 20 days remained until closest approach. 20 days to understand whether the past century of speculation, fear, imagination, and analysis had prepared anyone for what was coming. On April 5th, Chen addressed the United Nations General Assembly through a live video link from Hawaii. She stayed at the observatory because leaving felt impossible during such a critical period of observation. Every seat in the chamber was filled. Representatives from every country were present, including nations that rarely agree on global issues. Chen was not there to present technical data. Many others had already done that. She was there to answer a direct question from the UN Secretary General. What does this mean for humanity? She spoke slowly. Her response lasted only a few seconds, but it would be repeated across the world. She said, "It means we were never alone. It means the universe was watching, and it means that everything about how we understand ourselves, our place in the cosmos, and our future as a species changes today." The implications reach far beyond philosophy. They reach into daily life, culture, and identity. For thousands of years, people across civilizations have wondered whether humans are alone. Religions, stories, and oral traditions offered explanations centered on spirits, ancestors, or other realms. Modern science pushed toward evidence, asking for measurable proof and finding none. SETI listened for half a century and heard silence. Space probes searched and found only lifeless worlds. Thousands of exoplanets were discovered, but no signs of visitors. All of that changed with a single engineered object entering our solar system on a controlled path. Science historian Michael Shermer addressed this shift in an essay published on April 6th. He wrote that over 4 centuries, science has gradually removed humanity from the center of everything. Earth is not the center of the universe. The sun is one star among many. The Milky Way is one galaxy among countless others. And yet, through all of this, people still felt internally unique, an island of consciousness in a quiet universe. That belief ends now. Humanity is not the only intelligence. It may not even be close to the oldest or most advanced. Around the world, religious leaders responded in different ways. Pope Francis stated that intelligent life beyond Earth does not contradict faith, and suggested that creation across the universe is fully consistent with theological views. The Dalai Lama offered a simple statement: consciousness is not limited to Earth. Other groups reacted less calmly. Many evangelical churches saw a dramatic rise in attendance, some interpreting the event as a sign, others as a trial. A few called it an opportunity to rethink what it means to share existence with another form of life. At the same time, secular groups also released statements. The American Humanist Association emphasized that the existence of extraterrestrial intelligence does not change moral responsibility. People still shape their own future, still carry responsibility for one another, and still rely on evidence-based reasoning to guide decisions. Alongside the cultural debate, scientists looked at the technological gap, and the gap is enormous. 3I Atlas demonstrates control of gravitational waves, sustained high energy output, and propulsion with efficiency thousands of times greater than any technology on Earth. The systems visible from a distance show engineering far outside the reach of current physics. Theoretical physicist Michio Kaku appeared across news outlets during the first week of April, explaining the Kardashev scale, a measure of a civilization based on energy use. Humanity is roughly type 0.7. Since we use only part of our planet's available energy. A Type 1 civilization uses all planetary energy. A Type 2 civilization harnesses the full power of its star. A Type 3 civilization controls energy at the scale of its galaxy. Kaku paused during a CBS interview and said that based on all observed behavior, propulsion, power management, communication, and stability, 3I Atlas is operating at a level of at least Type 1.5, maybe approaching Type 2. The gap between us and them is like the gap between a stone axe and a nuclear reactor. Not metaphorically, not as hyperbole, but as a straightforward description of how far apart two technological lineages can drift when one has had thousands, perhaps millions of years more time to advance. In scientific briefings, researchers avoid dramatic words, yet even they admitted there is simply no other comparison that captures the magnitude. We are not in the same technological century. We are not in the same technological era. If their trajectory data, energy output, and gravitational wave manipulation are taken at face value, we may not even be in the same technological millennium. And that, more than anything else, is what keeps defense analysts, policymakers, and astrophysicists awake at night. Because once the gap reaches a certain threshold, all the familiar frameworks humanity uses to understand security interception, deterrence, threat modeling, proportional response collapse. Dr. Elena Volkov said it bluntly in a closed-door briefing in Moscow, a briefing that was leaked within hours. If they wanted our resources, they could take them. If they wanted our planet, we could not stop them. The only reason humanity still has agency is because they are choosing to give it to us. Her statement was clinical, not alarmist, and that made it even more sobering. It reframed the situation not as a conflict, but as an asymmetry so profound that conflict is not even a meaningful concept. We exist at their discretion. The Pentagon ran classified simulations. So did the Chinese Central Military Commission. So did NATO, India, France, and Japan. Every scenario, hostile contact, accidental escalation, territorial crossing, attempted interception, led to the same outcome. There is no meaningful pathway in which humanity prevails, delays, or even slows an adversary like 3I Atlas. Even in the simulations that granted humanity unrealistically generous advantages, the result was unchanged. The analysts stopped discussing victory. They began discussing survival, diplomacy, and symbolic gestures. They also began discussing something that no one had expected: the possibility that vulnerability could unite the world faster than ambition ever had, because something extraordinary happened next. On April 8, 2025, the United Nations Security Council, 5 permanent members who typically cannot align on even modest resolutions, voted unanimously to create the Unified Earth Contact Initiative. The vote was 15-0. No abstentions, no quiet objections, no rivals attempting backdoor amendments. It passed cleanly, swiftly, as if the Council understood that the usual rhythms of geopolitics no longer applied. The resolution mandated 3 core principles. First, that all space agencies share data on 3I Atlas openly and in real time. Second, that all military space assets be placed under temporary international coordination to avoid misinterpretation or escalation. Third, that any communication, response, or diplomatic action be crafted collectively and presented as the voice of Earth, not of individual nations. No country surrendered sovereignty, but for the first time, sovereignty felt like an outdated construct measured against what was approaching from interplanetary space. Dr. Naif al-Rodan, a geopolitical theorist, wrote later that day, 3I Atlas does not recognize our borders, our flags, or our competing myths. It sees one planet, one species, one civilization fragmenting into smaller pieces. Its presence forces us to consider whether those fragments still matter. It was not a call for utopia. It was an acknowledgement that the scale of the moment dwarfed the scale of our divisions, and yet unity never arrives without resistance. Nationalist movements around the world reacted instantly. In Paris, Washington, Moscow, Beijing, and dozens of other capitals, crowds marched with signs reading, "Do not surrender sovereignty. Earth is not a single nation. No unelected world governance." Some groups claimed 3I Atlas was a hoax created by global elites to centralize control. Others claimed it was real, but secretly aligned with the United States, or China, or a coalition of intelligence agencies. Still others insisted it was human technology disguised as alien, an ultimate false flag. None of these theories survived scientific scrutiny, but scrutiny was not their purpose. They were expressions of uncertainty and fear, amplified through social media ecosystems that reward emotional narratives over empirical ones. As governments struggled to balance transparency with order, the global economy faced its own reckoning. On April 9th, stock markets opened to the most chaotic trading day in a decade. Airlines fell by nearly 1/3. Tourism companies collapsed. Commercial space ventures, ones built on suborbital entertainment, saw their stock plummet as investors questioned whether their business models mattered in a world preparing for extraterrestrial contact. Defense contractors surged. Telecommunications companies shot upward as demand for robust global networks increased. Tech firms with any connection to satellites, energy research, or advanced computing experienced rapid speculative investment. Yet despite the volatility, the markets did not crash. After an 8% drop over 2 days, indices stabilized. Dr. Esther Duflo, speaking on Bloomberg, explained, "Markets behave not on what is happening, but on what must happen. In order for commerce to continue, 3i Atlas is not harming supply chains, threatening infrastructure, or disrupting demand. So markets are pricing uncertainty, not apocalypse." It was a strange admission. The global financial system, often criticized for fragility, was proving more adaptable than expected. She ended with a caution. "Ask me again on April 24th. But while institutions recalibrated, ordinary people were quietly adapting in their own ways. Despite fears of panic, suicide rates did not rise, crime did not spike, civil society did not fracture. People kept going to work, caring for their children, meeting friends, cooking dinner, streaming shows, living. Dr. Steven Pinker offered a simple explanation. Human beings normalize the extraordinary with remarkable speed. What is unimaginable on Monday becomes routine by Friday. He noted how commercial flight, once miraculous, quickly became mundane. "The same will happen with 3i Atlas," he said. "If it lingers for a year, people will complain about the lack of new updates." And yet something subtle was shifting. Church attendance climbed. Volunteer numbers rose. Charitable donations increased by nearly 1/4 in a single week. Psychologists began describing a new phenomenon: cosmic perspective taking. When confronted with something vast, ancient, and beyond human influence, people reevaluated what mattered. Arguments softened. Old grudges dissolved. Road rage incidents fell. Customer complaints dipped. Strangers held doors, helped neighbors, forgave small irritations. It was as if the species, for the first time, could feel the scale of the cosmos pressing gently against its daily concerns. A video posted on April 11th captured this shift better than any report. A high school student in Ohio filmed herself and her father standing in their backyard, searching the night sky. 3i Atlas was now bright enough to see with mid-range amateur equipment, an elongated point of light moving steadily through the darkness. The girl whispered, barely audible, "Dad, what if they're just like us? What if they were looking up at their sky, wondering the same questions, and they finally found us?" Her father was quiet for nearly 10 seconds. Then he replied, softly, "Then maybe we should make a good first impression." That short exchange spread globally, gathering hundreds of millions of views. Not because it was poetic, but because it was sincere. It captured the feeling that maybe we were being seen for the first time and needed to decide how we wanted to appear. As the days passed, the world's attention narrowed to a single point in the sky. By April 12th, with 11 days remaining before closest approach, 3i Atlas was only 1.2 astronomical units from Earth. Its infrared hotspot still glowed. Its rotation remained steady, and its silence since the last gravitational wave transmission on March 14th remained unbroken. No acknowledgement of the unauthorized CERN broadcast. No response to the countless mathematical messages, greetings, songs, and symbolic transmissions sent from governments, universities, and private citizens. Only approach, only trajectory, only an object traversing space with a quiet confidence that suggested intention without revealing purpose. Every professional observatory was locked into a continuous monitoring schedule. The International Astronomical Union coordinated a 24-hour rotation. Each hour, a different facility measured its position, emissions, spectral profile, and gravitational influence. The data was uploaded immediately to a public repository. Live telescope feeds streamed across the world. In Times Square, Shibuya Crossing, and dozens of public squares, Screens showed a glowing point inching through the starfield. Tens of millions watched the streams simultaneously. Hundreds of millions checked updates hourly. Even more followed the steady heartbeat of numbers scrolling across websites. Distance, velocity, brightness, trajectory. Dr. Chen was asked during a press briefing why everything was public. She replied calmly, "Because this is not the property of any nation or institution. This is a human moment, and in a human moment, transparency is not optional." The decision removed any possibility of secrecy. The species was watching together, whether or not it was ready, and that created a strange feeling across the scientific community. Predictability. 3I Atlas had made no unexpected changes since its earlier demonstrations. No new maneuvers, no deviations, no communication attempts. It followed the path that astronomers had projected, as if it wanted humanity to feel the rhythm of its approach, to understand that nothing it did was random. Predictability can be comforting, but it can also be unsettling, because when something vastly more advanced behaves exactly as expected, it suggests control, not improvisation. It suggests that the encounter is unfolding according to their timing, not ours. We are not conducting first contact. We are being granted first contact, starting on April 14th, with 9 days remaining before closest approach. NASA activated a plan referred to as the Contact Readiness Framework. Although the title suggested a structured and fully prepared system, the people involved recognized that most of the plan consisted of rapid adjustments presented in a clean, organized form. It was the best possible structure under the circumstances, but it was not a plan built from years of preparation. Instead, it was a response created at high speed to manage something entirely new. The framework was divided into 3 main phases. The first phase focused only on observation. All agencies were instructed to monitor the object, continuously tracking its motion, its rotation, its energy readings, and any signs of emissions. Under no circumstances would Earth send a deliberate signal unless the object initiated contact again. This guidance reflected the caution of the scientific community, which agreed that silence was, for the moment, the safest position. Phase 2 would begin only if a new transmission appeared. In that stage, the International Response Group would send messages made from simple mathematical structures, showing that humans could understand patterns. These messages relied on counting systems, geometric relations, and predictable numerical sequences. The goal was not to communicate deep ideas, but to show that the species receiving the signal had internal consistency and could follow shared logic. Phase 3 was left intentionally open. The official documents described it as an adaptive response that would change according to whatever happened next. This vague definition was not the result of secrecy. It reflected the limits of human knowledge. Experts admitted that no one on Earth had a model that could cover every possibility. They described the situation as one where flexibility mattered more than preparation, because a rigid plan would almost certainly fail against something unknown. During these days, observations continued around the clock. A tracking team in Australia, operating under the European Space Agency, noted a new pattern on April 15th. The rotation of the object had slowed again, continuing a trend that had started in January, from 6.7 hours to 6.9 hours, then to 7.1 hours. The changes were not surprising on their own. What mattered was the pattern behind them. The deceleration occurred in exact steps, decreasing by 0.1 hours at consistent intervals. No known natural process produced such uniform adjustments. The precision suggested that the rotation was being altered intentionally. indicating that the object had fine control over its motion. Researchers noted that nothing in the data suggested random physics. Every shift looked controlled, steady, and planned. While technical communities examined data, the global population engaged with the event in a different way. A simple website tracking the countdown to April 23rd became the most viewed page on the internet. Many people opened it repeatedly during the day, even though the numbers changed only by seconds. The countdown created a shared global rhythm. Social media, which often divides opinions, now carried a mix of humor, analysis, and reflection. Many posts attempted to reduce anxiety through light-hearted images, while others expressed hope, curiosity, or quiet concern. Large numbers of people wrote open notes addressed to any intelligence that might be observing the planet. These messages varied widely, but they often shared a common theme: a desire for understanding. At the same time, scientists modeled possible outcomes. Scenario building became a primary task for many institutions. The most likely scenario, estimated at around 40%, suggested the object might complete its closest pass, observe Earth in high detail, and then leave the solar system. A second scenario of similar probability predicted a new transmission during closest approach, taking advantage of the shorter communication delay. Another scenario considered the release of small devices for closer examination, though this idea created caution within military organizations. A smaller, but still possible, scenario proposed that no communication would occur at all, leaving Earth with data but no clear answers. A final category captured the remaining possibilities, the ones that could not be described or predicted. As the final week began, the object became bright enough to see with the naked eye. Individuals in many countries could look toward the constellation Virgo after sunset and locate it easily. It appeared brighter than most stars and moved slowly across the sky. At the same time, religious institutions of many traditions held gatherings, guiding their communities through the uncertainty with messages about unity and patience. Some observers noted that this was one of the few times in recent history where people around the world were focused on the same natural event at the same moment. By April 18th, with 5 days left, global markets had stabilized. Movements in major financial indices showed that the initial period of disruption had been replaced by a cautious equilibrium. Governments issued fewer statements, reflecting the limited availability of new information. The pace of activity slowed, leaving a sense of collective waiting. Many analysts compared the feeling to the moments before a major scientific announcement, where the world knew something important was coming, but not what form it would take. On the same day, a scientist involved in the monitoring effort received a message from an unidentified sender. The note referenced questions she had raised earlier and implied that Earth's long history of transmissions ranging from early radio broadcasts to deep space probes had contributed to drawing the object toward the planet. The message stated that these signals had been detected consistently across time. It ended by suggesting that the upcoming moment of closest approach should be observed carefully, especially in the form of wave-based signals. The lack of a known sender added to the uncertainty. On April 23rd, at 14:37 Coordinated Universal Time, the object reached its closest distance to Earth. Across the globe, teams at gravitational wave observatories prepared their instruments. These were the same detectors that had recorded the first mathematical signal weeks earlier. The staff at various facilities described the moment as one of focused anticipation. Their emphasis remained on measurement, not interpretation. They understood the importance of capturing every detail of whatever arrived next. As predicted, gravitational wave monitors registered a new patterned fluctuation. It stood out clearly against background noise. The waveform maintained a structure consistent with intentional modulation. Teams began immediate processing, converting raw signals into analyzable forms, isolating frequency components, and checking for repeated sequences. The initial findings confirmed that the transmission was deliberate and not a random event. This moment marked a turning point. For centuries, the idea that humanity might not be alone had remained a question without evidence. The new signal ended that uncertainty. From this point forward, the focus shifted from wondering about the existence of extraterrestrial intelligence to understanding the nature of the communication and the intentions behind it. The data indicated that an advanced intelligence originating from beyond Earth had reached nearby space and was continuing to send structured information. The next stage would involve decoding, interpretation, and establishing a framework for understanding the presence of a civilization capable of traveling between stars. The signal confirmed something simple but profound. Humanity was no longer isolated in the universe. The meaning of this fact, and the direction it would lead, would become the central scientific and cultural challenge of the coming era.